Hi everyone, this will be a continuation of our inverse trig notes, specifically looking at the connection between cosine and inverse cosine. So it's going to follow a very similar format to the notes we took for sine. So let's start by kind of titling the graph we're about to draw as a cosine inverse cosine connection. And just like we did with sine, we're going to start off with a quick sketch of cosine so we can reason on what part of the cosine graph will pass the horizontal line test. So we'll be graphing from 0 to 2 pi, getting our 4 key points. And we'll also go to negative 2 pi. Recalling our unit circle knowledge, we know that one full period goes 0 to 2 pi and the range restriction is between 1 and negative 1. Cosine starts at 1. Comes down to the x-axis, down to negative 1, back up to 3 pi over 2, finishes at 2 pi, does technically keep going forever and ever, and then from 0 to negative 2 pi, let's travel to the left, comes down to the x-axis, down to negative pi, back up to the x-axis, and finishes at 2 pi, and again keeps going forever and ever. If I apply, and you don't need to draw this, but just for emphasis, if I apply the horizontal line test to this graph, it fails horribly. We see it crosses once, twice, 3 times, 4 times, and remember cosine continues infinitely in both directions, so it's literally going to fail infinitely many times. Meaning that as of right now, if I were to take the inverse of cosine of x without a restriction, its inverse would not be a function because it is failing the horizontal line test. So just like we did with sine, let's see if we can reason out what restriction we've got. So if I start here on the y-axis and I start coming here to the right away I know I won't be able to go to the left because if I've already committed going this direction, if I were to include any part of the graph to the left, it would fail the horizontal line test. So I'm going to keep going in this direction and I'm going to see how far I can go without failing the horizontal line test. So far I'm good, I'm good, I'm good. Keep it going, keep it going, keep it going. And I need to stop right here. Because as soon as I come back up, notice, if I were to create a horizontal line right here, crosses once, that's okay, but check it out. Crosses twice, no good. So what we have highlighted in yellow is our restriction on cosine of x. That's going to be from 0, 1 to, and I would highlight this ordered pair so it stands out. What would this ordered pair be? Well, from 0, I go right pi and down negative 1. So pi, comma negative 1. And once again, I would highlight that ordered pair so it stands out in our notes. So let's compare side by side cosine and what this would mean about inverse cosine. So cosine of x restriction based on our graph here. We are going to be restricting the domain. If it helps in your notes, you can actually write out the word domain and make a note that's my input values. We're restricting the domain from 0, here's my x value, from 0 to pi. And my range, the y values of this function, are being restricted from 1 to -1. But if you listen to the order I said that, 1 to -1, that's not really following how we discuss numbers when it comes to domain and range, or those boundary values. We typically go from negative to positive. So when I write the range here, even though I technically said 1 first and then -1, we're going to be sure to write this as -1 to 1, least to greatest. So let's see what this is going to mean about inverse cosine, or cosine inverse, depending on how you would like to say it. From our discussion of sine and what inverse means in general, as a recall from those notes, inverse simply means switching our inputs and our outputs. So, get this set up here. If the inputs for cosine was 0 to pi, it will now be the outputs for the inverse cosine. So the domain became the range. In similar fashion, the outputs, the range of cosine, becomes the inputs for inverse cosine, or cosine inverse. They literally switched places, and if you really want to make that obvious to yourself, like, you could draw some arrows if you don't feel that's too messy in your notes. The domain became the range became the domain. We have literally switched the inputs and outputs. So reasoning on what this means, up until today, when I asked you to evaluate cosine of an input from 0 to pi, what I was really asking you to do was consider your input as an angle measure, and then when I gave you that angle measure, I asked you to go find the side length. Specifically, the x side length. For example, if I asked you to find cosine of pi over 6, right? Pi over 6 would be between 0 and pi. Up until today, you would sketch pi over 6, which is 30 degrees, and ask yourself, if you were on the unit circle, what are those side lengths? That is long x and short y, so that's root 3 over 2, comma a half. And if I was asking you for cosine, you would tell me the x value. So the answer, or the output, is the side length. We are now switching that. So now, instead of our inputs being angle measures, the input is going to be an x side length. You are going to be given the side length, specifically the x side length, and your job is to figure out the angle measure that corresponds to that side length. And I'm not going to put an example underneath because that's what we're actually going to do together in a minute. But what's in blue is, I would say, probably the most important point of these notes to really reflect on in terms of connecting old and new. So before we can actually do an example, we do need to come back and kind of reason on what this means relative to the unit circle. So let's just kind of put some notes here to have a frame of reference in our brains. Cosine of x is the x coordinate of the point that corresponds to angle T. So if I were to sketch myself a unit circle, and I were to just sketch an angle in quadrant 1, if I'm on the unit circle, I know that when I state my cosine, my x comma y, that gets me cosine and sine when I am on the unit circle. So we should add that. It's only when I'm on the unit circle that that ordered pair represents cosine and sine. And here's my angle T. So this is nothing new. We're just stating some prior knowledge. The new part that connects to it is the following. The range of inverse cosine, or cosine inverse, is restricted to, what is the range of inverse cosine or cosine inverse restricted to? Let's go take a look. We literally just wrote it down. So if I kind of share the screen with what we wrote before, my inputs will be side lengths, x side lengths between -1 and 1. And notice here, the range, the output angles have to fall between 0 and pi. So the range of cosine inverse is restricted to 0 to pi. All the angles that come from those side lengths have to fall between 0 and pi. Let's see what that means about where these angles could live on the unit circle. So here's 0. To get to pi, I'm going to travel to get to a positive pi, I'm going to travel counterclockwise. Here's pi over 2. I can keep going. And here's pi. So I have to stop right here. So I can go from 0 to pi. This highlighted section represents where all possible angle outputs can be for inverse cosine. So our concluding statement here is going to be values of cosine inverse of x are restricted to the upper half of the unit circle. And that's going to be a very helpful point for us when we go to actually evaluate some of these inverse cosine values. So let's get right to it. Let's practice. This corresponds to example 2 in our textbook. The title for that example is evaluate inverse cosine functions. And number 1 is inverse cosine of negative root 2 over 2. Let's take some notes to kind of have a frame of reference for what is actually happening here. So there's going to be 2 little notes that I write here. I want to ask myself, what am I being given? What does this input represent? And that's where the reasoning notes we wrote down can really help. So if we come back up here to what we wrote about inverse cosine, our inputs are an x side length. So when I read here where it says cosine of negative root 2 over 2, I literally can write for myself x side length underneath. And for the sake of the written note here, I'm going to write given x side length need to find that corresponding angle. Ask yourself, short x, long x, what angle has that x value? Now, just like when we did inverse sine, there's really not going to be a lot of algebra here at all. This is going to be 100% reasoning. Now, I know my angles for inverse cosine have to live between 0 and pi. If I have a negative x side length, right away I know I have to go left. So I'm going to be in quadrant 2. Now, asking this question, short x or long x, doesn't really apply to root 2 over 2 because our prior knowledge tells us that root 2 over 2 actually cuts this quadrant straight in half. The ordered pair, if I'm on the unit circle here, would be root 2 over 2, negative root 2 over 2, comma root 2 over 2. And that is the x value, so I'm kind of cross-checking my brain. Yes, I did sketch this correctly. And I have to ask myself, what angle measure gets me over here? What angle measure puts me at the angle where the x side length, right, to go from here to here would be negative root 2 over 2, is that value? Well, if I remember how to count by my 45s, so if I kind of trace this journey, you don't have to do this in a separate color, but I'm going to kind of provide some context. This would be pi over 4. We're going counterclockwise, so it's positive. 2 pi over 4 would get us pi over 2 at 90. 3 pi over 4. So the answer, you can fit it up here, we'll do that. Should have made these a little smaller. Is 3 pi over 4. This is all about x side lengths. Sorry about that. I think those are some remind messages coming through. Number 2, arc cosine of 2.5. So for this one, I have to kind of keep in mind what the domain, what my input values could be. Because remember, this is my input right there. So if I go back and I look at inverse cosine, the possible inputs, coming back up to what we wrote in blue, well actually above that, right here, my domain for inverse cosine is restricted from -1 to 1. So I'm actually going to make a note of that underneath this question, and my question to you is this okay? My domain is restricted -1 to 1. 2.5. Does 2.5 fit from -1 to 1? The answer is definitely not. It's too big. So we actually can't do that. So my answer is going to be does not exist, and I am done with number 2. This value is outside of the acceptable domain. Number 3 is inverse cosine of -1/2. So this is where that question of is that a short x or a long x comes into play. The fact that that is a negative x length means once again we will have traveled to the left to get to that negative x. So I'll be in quadrant 2. For some of us that might be thinking, what am I describing when I say short x or long x? Our two possible side lengths when we were on the unit circle, other than √2/2, which was always connected to 45, was 1/2 and √3/2. 1/2 is approximately 0.5, and √3/2, if you type that into your calculator, which I'm actually going to do right now, is roughly 0.8, I believe. So let's see. Calculator, where are you? I'm literally not finding it, guys. On my phone real quick. Hold on one second. Okay, here we go. So, square root of 3 divided by 2. Yep, 0.87. So 0.5 we describe as our short x because it's literally a shorter side length than 0.87. So this is a short x. Meaning that when I travel left, I would travel a short distance before moving vertically up. So if I were to sketch that angle with a short x, it would create a steeper angle. -1/2 √3/2. And the question is, traveling, in this case, clockwise, what angle gets you to that location where the x value or the cosine value, the x side length, so to speak, in this case cosine, is -1/2. Our answer, let's see if we agree, is 2 pi over 3. Because short x here, if I were to create that triangle, bringing blast from the past back, creates a 60-degree triangle there. And if I'm counting here from 0 pi, pi over 3 would be in quadrant 1, approximately right there. And to come this far past would put me at 2 pi over 3. It's positive because I went counterclockwise. So again, this is all about sketching the angle that has that as the x-coordinate on the unit circle. Let's now do some guided practice. I'm going to put all 3 up, and then I will freeze the screen, and I will pause the video to give you guys a chance to try them. And then when you press play again, you'll see the answers, and we'll see if we match. So the guided practice questions are, number 1, cosine inverse of negative root 3 over 2. Arc cosine. Remember, arc cosine is the same thing as cosine inverse, just a different way of writing it. 2.5. And last but not least, number 3, cosine inverse of negative 1/2. So go ahead and press pause. I'm going to press pause, give all 3 a try, and we will see how we do. All right, welcome back. Let's see if we match. Take a second to compare your answers to mine. For number 1, we get 5 pi over 6 because it's giving me a long x side length. Remember, that's approximately negative 8 point something. So that sends me out much farther than negative 0.5. So that corresponds to the ordered pair negative 3 root 2 comma 1/2 on the unit circle, which is, it does create a 30-degree reference angle with the x-axis. However, our count starts here at 0, or 0 pi. So you could see it as this would be 6 pi over 6, which does simplify to pi. You're 1 pi over 6 short, so that puts me at 5 pi over 6. Number 2 doesn't exist because 2.5 is too big. It's much bigger than the domain restriction that caps us at a 1. So 2.5 is definitely outside that domain, does not exist. And number 3, I think I actually meant to say positive 1/2, so I'll show you that in a second. We did do number 3 just now as part of our notes. But notice it's actually kind of nice to compare the difference here between this 30-degree angle, 5 pi over 6, and the 60-degree angle, reference angle, created. Notice the difference between a short x and the long x in the sketches. If I had, and I'm just going to put this off to the side, if I had asked you to find inverse cosine of a positive 1/2, that would keep me in quadrant 1, because that is literally a positive x value, a positive short x. Meaning, from 0, if I have to be a positive x, I would be going right instead of left for a side length. And that is a short x, meaning that literally a short distance x and a longer y. So that would be positive 1/2, positive root 3 over 2. That is the angle measure that would have positive 1/2 in the cosine position of that coordinate pair, which corresponds to a 60-degree angle here, reference angle, Because I'm in quadrant 1, that would put me at a positive pi over 3. So that wraps up our guided practice, and looking forward to any questions I get on sine and cosine inverse from numbers 1 through 14, which was assigned as homework tonight. Have a great night, everybody, and I look forward to your questions.